Many of you may not have heard of Crohn's disease, as it's a relatively rare condition, but we can all sympathise with the symptoms that patients suffer from, which are severe tummy pain and chronic diarrhoea. These happen because of damage in the large and the small intestine. And although there are drugs that can control and treat this damage if taken long term, over the course of their lifetime, up to half of all patients with Crohn's disease go on to develop scar tissue called fibrosis as a result of this damage. Scar tissue in the intestine, like scar tissue anywhere else in the body, leads to thickened and stiffened tissue. This ultimately leads to narrowing of the intestine and then to blockage to the flow of food. There are no medicines to either prevent or to treat fibrosis, so as things stand, when this happens to a patient, they have no option but to have major surgery to cut out the affected part of the intestine and to stitch the two healthy ends back together again. What do we know about fibrosis so far? Well, we know a reasonable amount. We know that it happens when a molecule called TGF-beta sends a signal to a cell called a fibroblast to transform itself into a myofibroblast and to produce collagen and other proteins. When they produce too much collagen, the end result is a thickened, stiffened fibrotic tissue I've just mentioned. Blocking TGF-beta itself is not a feasible strategy to treat fibrosis because it does too many other important things around the body and will lead to unacceptable side effects. So there's been a lot of interest and effort lately into figuring out exactly how TGF-beta transmits its message. Recent research from other scientists suggests that an enzyme called NOX4 may be needed to relay TGF-beta signal. And we therefore wondered whether blocking NOX4 might be a better strategy to treat intestinal fibrosis in Crohn's disease. To test this hypothesis, I'm taking two approaches. The first is to take samples of fibrosed intestine after the surgeons have removed it and to measure in the lab how much NOX4 is present. If, as we suspect, NOX4 is required for fibrosis, then there will be higher levels of NOX4 in the fibrosed intestine compared to healthy intestine. And this is what I have shown so far. However, by itself, it's not enough to point the finger of blame. If you see somebody standing next to a fire, you can't just assume they're an arsonist. They could also be the firefighter. So that's why I'm taking a second approach of promoting intestinal fibrosis in normal mice and also in genetically modified mice that lack any NOX4. If NOX4 is the arsonist and not the firefighter, then the mice who lack NOX4 will have fewer fires or less fibrosis than the normal mice. I don't have any answers to this part yet. If I can show that NOX4 is important and needed for intestinal fibrosis, then novel drugs that block NOX4 could be trialled for the benefit of patients with Crohn's disease.